Welcome back to the Path to Programming. In the previous episode, we learned about the budget tracking application that will be built in this series. I have finally settled on a name for this application. It will be called Simple Budgeting. If you haven't watched the first episode, please go watch it now. The link will be in the description. Today, I will be talking about modeling data in MongoDB. First, we will review how modeling data works in SQL databases. Next, we will look at the things to consider when modeling your data in a NoSQL database like MongoDB. Then we will talk about different database relationships and look at some examples of these. After that, we will conduct an experiment where we design the simple budgeting schema in a SQL style. This way we can see how it differs from NoSQL. Next, we will look at two very important topics in MongoDB. When modeling complex data, should we use an embedded document or a manual reference? Lastly, we will look at how the NoSQL document model will look for our three domain objects. Now, let's look at this diagram to the right. On the left side of the diagram, there's a relational database. RDBMS stands for Relational Database Management System. Popular relational databases are MySQL, Oracle, Postgres, and SQL Server. All of these databases store their data in tables. Each of those tables have columns with attributes like ID and name, and rows of data like 5 and Paul. On the right side of the diagram, there is MongoDB. MongoDB is a document-oriented database, which is one of the main categories of NoSQL databases. The other categories are graph databases and key value data stores. Other NoSQL options are Apache Cassandra, Redis, Neo4j, and Firebase. When I address NoSQL designs in this presentation, I'll be specifically talking about the document data model design. SQL databases have a lot of rules when it comes to data modeling. Much of the design focuses around the concept of normalization. Normalization's main goal is to not duplicate data. Normalization takes large tables and breaks them down into smaller tables and uses uniquely identifiable keys to link the tables together. The SQL design model is based on the relationships your data has with one another. For more information on SQL design and normalization, please refer to the links in the description. NoSQL databases are far more flexible than their counterparts. While adding a new column in a SQL data store may be difficult to do, it is much easier to do in a NoSQL data store. You are free to store lists of various object types in the same document. You can even store JavaScript functions in MongoDB. There are no rules to designing your schema with MongoDB. Denormalization is often encouraged, and data duplication is seen as no issue. You simply design your document model depending on your application's use cases. So, just think about the data you will need to query and design your documents in the most effective way for your application. Other benefits to NoSQL databases are that they are much more scalable than SQL databases, and they are much faster at handling large data sets. Now, let's talk about the different types of relationships that data can have. There's one-to-one. For example, Bob is a person who lives alone, and Bob has only one address. There's one-to-few. Sarah has a home telephone number and a cell phone number. There's one-to-many. A book has many pages, and those pages are unique to that book. Usually one-to-many has a lower limit of a few hundred and an upper limit of a couple thousand. There's one-to-squillions. like when Kim Kardashian tweets out to her 65 million followers. And then there's many to many. A teacher has many students in their class. Each student has many classes they attend with other teachers. Understanding what the relationship is between your data is very important in modeling your data in an effective way. Now, let's try to design a SQL schema for the simple budgeting app. This way we can compare it to the NoSQL approach. This application currently has three domain objects. There are users, budget allowances, and expenses. A user has a few budget allowances, could be up to 20, and many expenses. There are no many-to-many relationships, since expenses are going to be unique to each user, and given there are customizable budget allowances with a chosen maximum threshold amount, they also will most likely be unique. Here's how the schema might be structured in a SQL data store. Users are stored in the users table by their unique ID and username. The budget allowances table holds each user's budget allowances given by an ID, category, and a max threshold. This table contains a foreign key which links it to the user's table. Finally, the expenses table stores the date the expense was made, the amount, the category, and the description. This table also has a foreign key called user ID, which links it back to a user in the users table. This is a typical data model in a SQL database and would most likely represent how our data would be structured if we were using a SQL database for this project. Now, back to MongoDB. There are usually two ways to represent one-to-many relationships in MongoDB. Either you choose to embed your list of objects in the same document, or you reference or link it from another document, which is similar to a foreign key. The creators of MongoDB encourage their users to embed documents within each other. Of course, there are times when this might be a bad idea, but you should always think about if it's possible to embed your document before you consider linking. One to few relationships are usually great candidates for embedding. Here we have an example of a person with a few addresses. Instead of storing the addresses in another document, we have the freedom to store them right alongside of the person. This saves us from additional queries being made to fetch a person's address. Embedding documents is a type of denormalization. This technique could lead to data duplication. However, it can improve data access and might be best for your use case. So, when should I choose to not embed a document? When your list of data has to be frequently modified, this may be a sign that it needs to be in its own document. Also, if the data you are trying to embed needs to be filtered during the query, you may want to use it as a reference instead. When data is infrequently accessed, it may be best to put it in its own document or just query it when you actually need it. One example of this is an e-commerce website that stores products in one document and the parts list in another document. Most times, users will just be looking at the product description and images. The parts list is going to be queried less often in this case. If you are attempting to embed a list of data that can grow without bound, this definitely needs to be in its own document. Each MongoDB document that is saved in a collection has a limit of 16 megabytes. If your list of data exceeds that memory limit, your database performance will begin to degrade. Manual references are usually great choices for one-to-many, many-to-many, and one-to-squillion relationships. One of the major downsides to linking is having to perform additional queries. There's no concept of a join in MongoDB, so you'll have to query each document you link. I haven't looked into aggregation or the lookup function for MongoDB, but that might make things easier. In the example shown to the left, instead of duplicating the book publisher in the book collection, we have chosen to reference the books from the publisher. So then when you look up a publisher, you can see what books they have published by querying the books collection using the book IDs. Okay, so now let's utilize what we've learned to design the simple budgeting document model. So we have a user with a few budget allowances. According to best practices of MongoDB schema design, it would be best to embed budget allowances within a user document. From our application use case, we will not be frequently adding, removing, or deleting budget allowances. Users may modify and add allowances from month to month, but it won't be done on a regular basis. We can store the user ID, username, and their associated budget allowances all together in the user document. This way, when we want to find a user, we also get their budget allowances. This also aligns with my idea of how users will register. When a user registers for simple budgeting, they will create their initial budget allowances during the time of registration. This way, when a user is first added to the database, their allowances are also added at the same time. A user's expenses are regularly added and grow without bound. When displaying the expenses of a user, we want to be able to separate them out by category and month. That way, users can see how much they've spent in each category for the current month. If the expenses were to be embedded in the user document, then we would have to apply filtering after the fact and would result in very slow query times. Imagine just wanting to get 3 grocery expenses from July, but having to filter it out of 1,000 total expenses. For this reason, expenses will be stored in its own collection. Each expense document will contain its own unique ID, the username that this expense belongs to, a transaction date, an amount, a category, and a description. Now, I didn't arrive at this design initially and had to fight against MongoDB for several iterations until I found that this model is best suited for this application's use cases. Well, that's all I have for you in this episode. On the next episode, we finally begin coding. We will focus on the database level and particularly the user domain. We will learn about how to use Spring Data MongoDB and Mongo template to interact with MongoDB in an easy and intuitive way. To ensure we are doing everything correctly, we will be writing integration tests using an embedded MongoDB database. I hope you've learned a lot. Thanks for watching. If you're enjoying the content, please like, comment, and subscribe.